Hi everyone, this is Asha. I'm working as an assistant professor in the Department of Artificial Intelligence and Data Science. In this series, I'll be teaching the subject Design and Analysis of Algorithms. Each video will cover one topic in a clear and simple way. Let's get started. Hello students, our next topic is Warshall's algorithm. So this comes under dynamic programming. As we all know, dynamic programming is one of the optimal algorithm technique. That is, the basic idea lies in recording the solutions to overlapping subproblems of a given problem. And from that, we will obtain a solution. Okay. So the common examples of this dynamic programming approach are like computing a binomial coefficient, Warshall's algorithm, Floyd's algorithm, optimal binary search tree. Likewise, we have several. So in this video, we are going to see about Warshall's algorithm. Let's start. Okay, students, just now observe the question carefully. See, the question can be given like in general, that is, relate the algorithm which constructs transitive closure of a graph. Or else they will give a matrix and they will ask you to apply the Warshall algorithm. So the question can be in any form, but the term which we have to observe is nothing but transitive closure of the digraph. Okay, that is very important. So either the question will be general or the matrix will be given. Okay, what is meant by transitive closure? See, it is actually a Boolean matrix. Matrix in the sense the values will be either 0 or 1. That means we are going to construct a graph, right? So if the graph is given or if you are constructing the graph from the value, so if it is 0, that means there is no connection. If the value is 1, then there is one connection. Connection in the sense edges, because all are what? Vertex. From one vertex to another vertex, you will be having one connection, one line. That is termed as edge. So if there is 1, then both the vertices are connected. If it is 0, that vertices are not connected. So now we will see how to construct a digraph from the given matrix. From the given matrix, now we are constructing a digraph, that is nothing but directed graph. So already I meant if it is 1, then there is a connection between two vertices. If it is 0, the two vertices are not connected. There is no edge. Got it? So now when you observe the digraph, it will be very clear that there is a connection only for A to B, B to C and C to D. Now let us start solving or applying the Warshall algorithm. So the matrix which we have constructed now, or the matrix which is given already, whatever may be, it is termed as what? Adjacency matrix. Okay? And first, the matrix initially it is named as R0 or R0. First, we are going to construct one by one, that is R1. When we are constructing R1, that is for first vertex, there will be an intermediate vertex. Okay? That means for example, if I am connecting A to B to C, means B is acting as what? Intermediate. So one element will be acting as an intermediate. So the starting and ending point will be different. It is passing via that particular vertex. So if for example, if it is A to B and B to C, means here B is intermediate, likewise. But for each, we will be considering intermediate vertex as A, and next it will be AB, like that. So let us start one by one. So first, initial matrix which we have constructed or which is given in the question is what? R0. Now we are going to construct R1 by keeping one intermediate vertex as A. Okay? Now let us start the process. So this is the initial matrix R0. So R0 is a matrix which is given or we will be constructing. So if the matrix is given, we have to construct a digraph. If the digraph is given, then we have to construct the matrix. So it is a matrix of Boolean values, only 0 and 1. When it will be 1? If there is a connection between those two vertex. Okay, so for example, if A and B are connected, then you just observe the matrix, it will be 1. If look at B and C, if it is 1, then B and C got connected. So if there is a connection, then the Boolean value will be 1, or else it will be 0. Okay, now let us start constructing the first matrix R1 from R0. So here the intermediate will be A. That means if any edge is passing through A, then we can change it as 1. Okay, but if you observe the diagram, there is no connection between D to A. In case if there is a connection between D to A, then I can say D to B will be changed as 1. Because what is the meaning of intermediate? What did I say? Through A it will pass. Via A it will pass. That means the starting and ending will be different. The intermediate node or vertex will be what? A. So if there is a connection between D to A, then we might have got D to B as 1. Since A is not connected, we cannot do anything. So R1 remains same. But when you observe R2, now we are going to construct R2, right? So you just see A and B remain same. Just look at the matrix in the first row. A to C. See, A to C means now what are the intermediate elements? A and B. In R2, the intermediate elements are A and B. In R1, the intermediate element is what? A. So now A to B, B to C. So via B, A is connected to C. It is not directly connected to C, but via B it is connected. So there, instead of 0, I can change it as 1. Okay? But other than that, we don't have any other changes. So from R0, there is no change in R1, but there is one change in R2, because here the intermediate element is A and B. So through A and B means there is a connection for A to C. Okay? Now let us construct the third matrix, that is R3. So now the number of intermediate will also increase. In R1, what was the intermediate element? A. In R2, what was the intermediate element? A, B. Now in R3, what are the intermediate elements? We have 3 elements, A, B and C, or you can say node A, B and C. So that means which is passing through A, B and C. So when you observe A to D, there is no direct connection from A to D. But I can start from A and I can reach D through the nodes B and C, or through the vertex B and C, because they are intermediate elements, right? So now I can change that 0 as 1. Likewise, B to D. You don't have any direct connection to B to D, but via C I can reach D. So 2 changes when compared to R2 matrix. Okay? See, R0 and R1 are same. There is no change. But in R2 you had only one change. But in R3 you are having 2 changes, because here 3 intermediate elements are there. A, B and C. Understood? Okay, now the last matrix, that is R4. Now all the 4 nodes are intermediate, that is A, B, C and D. But when you see, as I mentioned earlier, if there was any connection between D and A, then we might have got some changes. Since there is no connection between A and D, there is no change. Okay, so we cannot do any connections, we cannot pass anything. So that means R4 remains unchanged. It is equal to R3. So we have to mention it. R3 is equal to R4. Now this is our final resultant matrix. Thanks for watching.